Hi everyone, welcome to Trigonometry 2 for Pre-Calculus. The first question is express in simplest form 4 minus 4 cosine squared x over sine x. The first thing I did was factor out the 4. 4 times 1 minus cosine squared x over sine of x. Remember your Pythagorean identity, sine squared x plus cosine squared x is equal to 1. 1 minus cosine squared x is equivalent to sine squared x, so that was replaced in. The signs go away, and I'm left with 4 sine of x. Number 2, express in simplest form, secant squared x minus tan squared x. 1 over cosine squared x is equivalent to secant squared x, and tangent squared x is equivalent to sine squared x over cosine squared x. Because they have a common denominator, I'm able to subtract the numerator, 1 minus sine squared x over cosine squared x. 1 minus sine squared x is equivalent to cosine squared x. Cosine squared x divided by cosine squared x is equal to 1. Number 3, find the exact value of sine of 105 degrees. Now remember, we don't know 105 degrees, but we do know 60 and 45, and 60 plus 45 is equal to 105. So we use the formula of sine of 60 plus 45. Replace in what sine of 60, cosine of 45, sine of 45, cosine of 60 is, and the answer is radical 6 plus radical 2 divided by 4. Number 4, if tan of x is equal to 3 over 4 and 0 is less than x less than 90, what is the value of sine of x? So we know tangent is opposite over adjacent, so I do a right triangle in the first quadrant. This is a 3, 4, 5 triangle. Therefore, sine is opposite over hypotenuse, so sine of x is equal to 3 divided by 5. Number 5, what is the radian measure of an angle whose measure is negative 240 degrees? Remember, we multiply this by pi over 180. We simplify negative 240 divided by 180, so that's equivalent to negative 4 pi divided by 3. Number 6 is a factoring question, 3a squared plus 14a minus 5. Multiply 3 times negative 5 to give you negative 15. And what multiplies to negative 15? 15 and negative 1. This becomes a grouping question. Group the first two terms together, the last two terms together. Make sure the binomials in the parentheses match, which they do. And you're left with 3a minus 1 times a plus 5. For number 7, simplify and express your answer with positive exponents only. So x to the negative 3 times y squared divided by x to the 4th, y to the 5th. So I brought x to the negative 3 to the denominator, which becomes positive. And then remember, when you're multiplying, you add the exponent. So 3 plus 4 is 7. And then in terms of y, I subtracted because I'm dividing. So 2 minus 5 is negative 3. But if I have a negative 3 in the exponent in the numerator, it can go to the denominator to become positive, which is equivalent to 1 over x to the 7th, y to the 3rd. For number 8, it's the same idea. Simplify and express your answer with positive exponents only. A to the 7th divided by k to the negative 5th. If there is a negative in the denominator, you bring it to the top, it becomes positive. A to the 7th, k to the 5th. For number 9, identify the midline of the following function. F of x is equal to 78 plus 3/4 cosine of 4x. The midline would be y is equal to 78. And number 10, identify the period of the following function. Y is equal to negative 3 sine of 1/4 x plus 7. The period is 2 pi over the frequency. The frequency is 1/4. 2 pi divided by 1/4 is 8 pi. Number 11 on the next page, it says prove cotangent of theta, sine of theta, cosine theta is equal to cosine squared theta. So all you have to do is simplify. Cotangent of theta is equivalent to cosine of theta over sine of theta. The signs cancel out. Cosine of theta times cosine of theta is cosine squared theta. So the left side is equal to the right side. If sine of A is equal to 3 over 5, cosine of B is equal to 5 over 13, and angle A and angle B are in quadrant 1, find cosine of A plus B. Now, if we have sine of A, we also need sine of B, and cosine of A. If we have cosine of B, we also need sine of B and sine of A. So what we have to do is draw out the right triangles. So the A triangle is a 3, 4, 5 triangle, and the B triangle is a 5, 12, 13 triangle. Then replace in, and you end up getting negative 16 over 65. Number 13 is a proof question. Secant of theta, sine of theta over tangent of theta plus cotangent of theta is equal to sine squared theta. So I simplified secant to be 1 over cosine, and sine I left alone. Now the denominator, I simplified tan to be sine over cosine, cotangent to be cosine over sine. Now there's an addition in between those two fractions, so you need common denominator. So I multiplied the left side what's missing, which is sine of theta over sine of theta. The right side, cosine of theta over cosine of theta. So if you notice here, I'm left with sine of theta over cosine of theta for my numerator, divided by sine squared theta plus cosine squared theta over sine theta cosine theta. Now notice this is the Pythagorean identity, so we can replace that with the 1. This becomes a keep, change, flip question. So we're keeping the first, changing the second, and flipping the last. And I end up getting sine squared theta. In question 14, find the nearest degree all values of theta in the interval of 0 to 360 degrees that satisfy the equation 3 cosine 2 theta plus sine of theta minus 1 is equal to 0. Now, because I see cosine of 2 theta, I look at my formula sheet, and I choose the formula that has a sine in it so I can solve in terms of sine. So I place that in with 1 minus 2 sine squared theta. I distribute the 3, I multiply, and then it turns into a factoring question where I let x is equal to sine of theta. I pull out that negative 1. I factor using grouping. Remember, the two binomials have to match, which they do in fact, and I get 2x plus 1 times 3x minus 2 is equal to 0. That's when I replace the x with the sine of theta. I get sine of theta is equal to negative 1/2, sine of theta is equal to 2/3. Sine is negative in the third and fourth quadrant, and sine is positive in the first and second. So my answer should be 4 different degree values. So 30 and 42 are my reference angles. Now 42 is one of them. Then I find 180 minus 42 to be 138. 180 plus 30 is 210. 360 minus 30 is 330. So each one of those angles are in the 4 quadrants. Number 15, if x is a positive acute angle and cosine of x is equal to 1/8, what does sine of 1/2 x equal? So I use the half of sine x formula, which is plus or minus radical 1 minus cosine of a divided by 2. We know that cosine of x in this case is 1/8. Replace it in. I changed 1 to be 8 over 8. Simplify. Radical 7 over 8 divided by 2. Keep, change, flip. 7 over 8 times 1/2 is 7 over 16. Take the radical of both the numerator and the denominator. Radical 16 turns to 4, so radical 7 over 4. And I'm only looking for the positive acute angle, so it's just positive radical 7 over 4. And lastly, number 16, solve for x to the nearest degree in the interval 0 to 360. 2 times 3 sine of x plus 1 is equal to sine of x. So first you distribute that 2. 6 sine of x plus 2 is equal to sine of x. Subtract sine of x over to the left-hand side. 5 sine of x plus 2 is equal to 0. Subtract the 2 to the right-hand side and divide by 5. Sine of x is equal to negative 2 over 5. So I'm going to put that in my calculator, and I get a reference angle of 24. So remember that sine is negative in the third and fourth quadrant, so 360 minus 24, 180 plus 34, and I get 204 and 336. Hope this is helpful. If you have any questions, please feel free to chat on the Teams. Thank you so much. Have a great day.